Hey everyone, I'm Chris with Exodus, and it's time to remove the complexity of crypto and share some non-technical blockchain knowledge for the rest of us. Today, we're going to unpack proof of work and learn what it is and why it's used for popular cryptocurrency projects, as well as its pros and cons. Let's get lit. Proof of work is a consensus algorithm that acts as the governance on a blockchain network and means exactly what it sounds like. Let's take your job, for example. You go to work and rock your job. At the end of the pay period, you receive your salary. Your salary is the proof and the reward of the work you performed. Proof of work in the blockchain is no different, except it allows for this governance to be distributed and trustless, meaning you don't have to take anyone's word the work has been performed. The proof and single source of truth is in the next block being created. The most popular coin using proof of work is Bitcoin. And when you hear things like mining, miners, solving blocks, and transaction confirmations, to name a few, these all have to do with proof of work. Without getting into the nitty-gritty of blockchain technology, it's merely a large amount of data organized in a way so the data previously added to the chain can never be altered. The way this is accomplished in a proof of work system is by massive amounts of computing power verifying or solving all the transactions in a block. We can look at this as a complicated math problem or a puzzle, which takes a global supercomputer made up of competing miners to solve. There is, however, a large amount of competition to solve the equations, making the process very difficult. We'll revisit that in just a minute, but first, we'll take a look at the brief history of blockchain proof of work. Taking a stroll over to Wikipedia, we find that the proof of work concept was invented in 1993 and formalized in 1999. The first implementation of proof of work was in a protocol called Hashcash and is still currently being used on the Bitcoin network today. Bitcoin uses this hashing function to mathematically solve the puzzle. Once solved, a hash is created. The way this works to maintain the integrity of the blockchain is each ending hash in a block is the same as the first hash in the next block, creating a chain of blocks, or a blockchain. We call these math-solving machines miners because they're mining for data to solve, and once solved, receive a block reward. In the case of BTC, the reward is newly created Bitcoin added to the miner's address. The amount of energy it takes to solve these puzzles is represented in hash rate. As you can see in this graph, the current hash rate is 100,000 petahashes per second. Now, just to give you an idea of scale, 1 petahash equals 1 quadrillion. That's not a number you hear every day, unless you're a Bitcoin miner. What this represents is the computational or work being done on the current Bitcoin block. For the proof of work system to operate smoothly, a balance is needed between how difficult or how easy it is to mine a block. If the hash rate is high, then the network makes it more challenging to solve. If the hash rate is low, the problem becomes easier to solve. This adjustment is what's called the difficulty rate. The Bitcoin protocol is built so blocks should be solved and a new block created every 10 minutes. If solving a block goes longer than that, transactions can be stuck for a really long time. This difficulty rate is adjusted every 2016 blocks, which is roughly every 2 weeks. So right about now, you think it's a good idea to get into Bitcoin mining. Before you run out and purchase a shiny new mining rig, you'll need to do the math on the current return of your investment. Hash rate's not cheap. The equipment cost plus the energy usage might make mining solo prohibitive. Remember what I said earlier? There's a lot of competition to solve blocks, meaning you might mine solo against colossal mining farms and never mine a single block. If you still have the mining bug, then you can dive into a mining pool. A mining pool is a group of small miners working together to increase collective hash rate, increasing your odds at solving a block. The advantage of using proof of work is receiving block rewards from mining. The disadvantages are the amount of competition, the high cost of equipment, and the energy required to mine. Proof of work is also susceptible to what's called a 51% attack. This is when a single entity controls over 51% of the entire hashing power, thereby giving them control of the governance of the network. This means they could change the consensus rules or reverse transactions. Now, this could be disastrous for a coin, and usually, if there is no contention to the protocol, competing miners will actually work together to make sure no one reaches the 51% threshold. As mentioned at the beginning of this video, Bitcoin was the OG proof of work coin. Other popular coins using proof of work are Litecoin, Ethereum, Bitcoin Cash, Bitcoin SV, Monero, Zcash, and a whole host of others. Leave a comment and let us know if this video helped you understand how proof of work works. And if you have some crypto topics you'd like us to cover on the Crypto Lit series, toss them in the comments as well. For more crypto videos, check out the videos on the right. And please hit the like and subscribe button to see more from Exodus. Until next time, hold on.